Good morning, good afternoon, and good evening, ladies and gentlemen. This is Glenn Tan speaking. This time, we're going to talk about photovoltaic direct-driven GMV, short for PV-GMV. This presentation is based on the Middle East and North American models. The difference between these two is the power spec, and based on the power spec, how to select the PV panels. Later, I will talk about the detail. As for the other functions, they are completely the same.
This presentation divided into these 5 parts. First is the product introduction. And this is the product lineup of all our green PV products, including the air conditioner for household use, split tie, and this is our famous PV-GMV for VRF. And also we have the rooftop. It is very popular in Middle East and Africa area. And also we have our centrifugal chiller. It is PV. And also currently we are developing this cold storage. Also we use the PV energy. Today we just focus on this PV VRF. Maybe other manufacturers also claim that they also have the PV VRF, but actually it is not that same. And here I will explain how they work. So you can find it on this graph. This is for example the regular VRF, and this is the converter. It's handling the power, either it's from AC, which is from the grid power supply, or from the DC, is from the PV panels. So for this case, this converter need to, for example, if get the power from this DC, and you need to convert this DC to AC, then power to the regular VRF. And for the compressors and fans inside, if they are DC, which is very popular, they need to convert this AC to DC again, then to drive the inside compressor and fans. So the total convert loss there are 6%. It is for 2 times. But for our PV-GMV, which is this one, so you can find it. We also have a converter, but it is built in, which means this is actually the regular VRF, and we buy them together. So on the side, you just need to connect the power from the grid power supply, which is AC, and then here is the power from the PV panels is DC. We can use the DC to drive the inside compressor and fans, so we can eliminate this 6%. And on the other hand, this can also improve the construction speed, as you don't need to set up the converter, so it's easier for you to install it. So for the Mood 2 is uploading to the grid, and this require the local policy, which means the local policy, if it allow, you can upload to the grid power supply to earn some money. And for this one, first is pure PV power generation. That means if this PV GMV, which this one is not working, so at that time, here the PV panels still generate the power, and then you can upload to the grid power supply to earn the money. And the next is the balance, which means here generate much, then we can also power the PV GMV and also uploading. This is the perfect, right? And also for this tool, and also once setting, there's no need to change. And for the third is PV storage integration. That means if not allowed, or you don't like to upload to the grid power supply, you have a third option, which is to stop the abandoned power to this what we call energy storage unit. So at this you can find it that is actually a transformer, which is we will lower the voltage of this DC and then stop the power to this battery. Actually for this one you can buy it from Gree, or you can just prepare yourself and just follow our requirements. It's okay. And for example, in daytime you can stop the abandoned power to here, and after sunset, or if the power from the PV is not enough, you can also get the power from this. And for the fourth mode is to offer the power to other home appliance. In this case, you can find that here we stop the power at the battery, and we can offer the power from here to the other home appliance. Actually here it is auto DC, you can apply the DC to AC transformer, then you can get the AC current. Then you can power on the other home appliance, either it is DC or AC. And also for this one, we require engineering customized. For the fifth mode, it is off-grid PV system, which means at this system it is isolated from the grid, which means you can get the power 100% from the PV panel or from the power generator. At this case, you have two options, which is to first one, to use this energy storage unit. We can stop the power from the PV panel and to here, and then from here we can offer to the PV GMV, and also you can offer to the PV GMV in dock units. And the other option is just to apply this power generator, and this one is similar to the grid, which the output is already AC, so we can power on this PV GMV. They can combine the DC, which is from the PV panel, and this AC together. And the next is I will introduce the core technology. For our PV GMV, there are these 5 technologies. Actually, it is a little bit complicated, and also from the name you can also find it. And actually, for this one, the power generation and consumption management, and this is just will making the power consumption and power generation to be visualized, and also this is convenient for you to analyze and management. And this PVG1 direct G1 technology, that means we can drive the inside complexer and the fan motors directly from the PV panels, which is also DC, and so we can higher the efficiency by 6 to 8%. As for this 3, the PAWN interleaving technology, multi-converting technology, and dynamic load tracking and PPT technology. The 3 of is aim to lower the PV power fluctuation, as you know that, especially when it switch from the PV panels power to the AC power, which is from the grid power supply. If the tie loss is too much, it will make the compressor to stop. And for this 3 technology, we can avoid this.
At second part, we will talk about PV equipment selection. At this part, I will show you the difference between the Middle East and North American models. And please pay attention to the title and also the model of the unit.
This is the side discharge, so you can find it from the area runs. It is actually the GMV minute just plus the PV functions, and also the capacity is the same from 12 to 16 kilowatt. And as for its PV parameter, you can also check it on the service menu, which is this part. And the most important is this one, 5 kilowatt, and also this max DC input voltage. As for the top discharge, this time for the single outdoor unit, it is from 22.4 to 63.5 kilowatt. Also, it can be modularized, and the total it can be up to 134 kilowatt. And actually, the appearance and also the inside components is the same as the regular GMV5. What's different is there is a built-in converter, this one. And as for its PV parameters, you can also check on the service menu, which is this one. It is important when you're going to select the PV panels. And this is for the side discharge. For this series, we have 38 to 60 kBTU, and although it cannot modularize, but it's very good for the household use. And actually, this one is, you can find it is very similar to the GMV Mini, and the answer is yes. And actually, it is the GMV Mini, but plus the PV function. So on the service menu, you can also find this parameter. It is the PV parameter, which is very important for you to do the selection. And as for the torque discharge, and it is similar to the GMV5, which means for the single unit, we have 62, 96, 120 kBTU, and for modularized, which means we can put different outdoor units together to enlarge the capacity. So we can make this to be 360 kBTU. And for this one, is actually the regular GMV5 plus this converter. It is built in, but actually for the North American market, we make this separated for the delivery. And also for the PV selection, this is the important parameter. You can also find it on the service menu. And later I will show you how to do the selection. As for the indoor units, for this part is completely the same as the regular VRF. And this is the centralized controller special for the PV-GMV. And here is the model. And as for the connection quantity, it is the same as the regular VRF system. What's different is, and you can find it from here. Actually, this is very similar to the CE53, and the difference is just here. From here, it will show you the detail of the PV system. So you can find it. We already display the how much power this VRF consumes, and how much power from the PV panels, and how much we get from the grid power supply. And also this 3 icon here, you can click on it, and then it will show you the detail. The first one, we will put it all in the parameter, and the next is press here. And also we can see this one. This is we make the data to be curved, which is much more convenient for you to do the analyze and also the management. And this one is another curve. And this is the centralized controller and how to do the wiring. And also similar to the CE52, and here is the terminals of the CE55. Here is for the power supply, And in the system, for this part, it is the same as the regular VRF, and this is connect with the in slave indoor unit and outdoor units. So this is the master outdoor unit. From the master outdoor unit, if there are only one system, you can connect from the D1, D2, which is from here, then connect to here, which is here, the G1, G2. And also don't forget the matrix resistor to ensure the communication. This is for single system. If it is a multi-system, only from the master G1, G2, just like this. And they can combine together from here and then connect to this G1, G2. As for this F1, F2 is for the fire alarm, and once we see the fire signal, this centralized controller will stop all the online operation. And this is the energy storage unit, which it is the battery. And also you can connect with the G-IEMS system, which later I will introduce. And the purpose of it is just to stop the power. What you can do is we can adjust the electricity for the price at peak hours. That means, for example, if in your local, if the electricity fee during the daytime and nighttime is different, so we can adjust this part, which means we can stop the energy during the daytime and use it in the night. And the next is the G-IEMS system. And first is this is the topological, and for this one, and this is the PV system, which is the outdoor unit and the indoor units, and also including the PV panels. And for this one, also from the master outdoor unit, from G1, G2, you need to connect to this gateway. And here is the model. And also for this system, you still need to install the power meter. One is for DC. This is to calculate or to measure how much power you get from the PV panels. And also another is from the AC. This is to measure how much power you get from the grid power supply. And if it is available, which means you can upload the power, we can also measure this part. So for this one, it is a binary, which is from and to the grid. And after that, from here, you need to connect to the server on the Ethernet cable. Then from here to a PC. So from the PC, actually it's on the west side. You can also control and check the system information. And this is the homepage of the G-IEMS system. Its function is all engineering customized, which means you can change the detail. Just contact with our salesman. And also you can check and do the management from your smartphones. And here I will just show you a project which is in Dubai. So from here you can find it when you go into this website. Here you can make a selfie to introduce what's the project, and also this is DIY. And for this data, we make the power consumption for every day, for every month, so make it to be curved. It's better for you to do the analyze. And also you can find from here, this is the PV panels, this is the storage, the battery, And here is the how much power you consume, and here is how much power you get from the grid power supply. And also on this one is the CO2. We make it to be a CO2 animation, which is more popular. And on the other hand, you can also check and control the in-dock units from this software. And from this one, from this example, you can find it. This is display how the in-dock unit works. And just click one, and here is the control page. You can control the in-dock unit to operate.
And the third part, we'll talk about how to do the design. For the outdoor unit, it is the same with to the regular VRF to select the size or the capacity, which is based on the indoor unit. Just based on that to select the outdoor unit capacity is okay. And this part is focused on how to design the PV system. And as the difference between the Middle East and North American, I will divide it into two parts to talk about this. Also pay attention to the titles and also the models of the unit.
And first, you need to check how much the solar power for your local. And here is two methods. First is you can check from the NASA website, and the other is from this software. From here, you can get the average solar power for LV squared. So after that, you can select the PV panels. And our grid can also offer the PV panels, and currently there are three models of it, and you can find it the size, they're the same. The difference is the max efficiency and also the power output. And when you select this one, and you need to ask the manufacturer what is the efficiency and also the power. And this is the detail of these PV panels. And for your selection, this parameter is important, which is the maximum output of this of each panel, and also this four, the max wattage and the open circuit wattage, and also these two. And this five parameter is very important for you to do the selection. After selected the PV panels, and then you need to combine them together as a string and connect this string to the PV outdoor unit. And the first step is to calculate how many panels for one string. And the formula is this one. And then the next is to calculate how many strings for one outdoor unit. And the formula is this one. And for this also you can find it. This is the P is for the max DC power of this solar outdoor unit, which we listed on the service menu. And here the PS, that means the N, this is the quantity of one string, which is this one. At the step 1 you calculated value. And this WP, that means the maximum output of this panel. And of course, for this one, for the finally you can get this string quantity. The higher of this value, that means you can connect more strings. Also means you can save more power. So I will show a detailed example to do the calculation. And also you can find it, there is we also make Excel files. This is for quick calculation only. This is the detail to do the selection of the PV system. When you open this Excel files, it will display this table. So on this table, this part is the parameter you get it from the PV panels, including these 5 parameters I just mentioned about, and this part is the parameter you can get from our outdoor unit, and which is for example, you just select this outdoor unit, and this parameter you can check it from the service menu, and from here you need to input the max DC input to here, and also the MPPT range to here, and then this part is your local ceramic temperature during daytime, so also input it, and then you can get the value directly, which is this one. And for this case, for one string there is 11 panels, and the next question is how many strings for this outdoor unit. If we just follow this formula, which is this one, this S equals to this P. This is this one, the max DC input. You can also get it. It is 5 kilowatt, and this is the quantity, which is this one, 11, and this WP is the max power output of one PV panel, which is this one. So the answer will be this, which is only one string for this outdoor unit. And how about for the torque discharge? And this time we just select this one, and it's for the PV panels, no change for this model. And what is different is this part. Also we can input this parameter, which is from the service menu, and input this one to here, so we can get the quantity for one string is 22, and for how many strings, just follow this formula, and we can also get this max PV power from here, and the result is 3.52. After round down is only 3. So the answer for this one is only 3 strings, and every string is 22 pieces. And here I just make a summarize for your reference. So for the VRF, torque discharge and side discharge, and how many pieces for one string, and the total how many strings we need, and this is the total quantity of the PV panels. And as for the PV panels, it also has its lifespan is about 30 years, and the decay factor is less than 20%. So this is the Excel file. When you open it, it will just display this table. For example, this time we already selected the outdoor unit to be this one, and on the service menu we can get the PV parameter of this. So from this selection table, this part you need to input the parameter of these PV panels, including this Pmax and the other 4, and also this one you can get from here, and input from to here, and then this one is your local temperature. You need to input it, and the last it will automatically coming out how many panels for one string. From this calculation it is 10. And then the next step is how many strings for this outdoor unit, right? So also from this formula, this P is this one, the max PV input power. From this one is 6. So you put into this formula, you can get this result to be this is only one string, and one string is for 10 pieces of the PV panels. And for the other case is, for example, this time we just select the torque discharge. It is this model, and also this parameter you can get it from the service menu. So from the calculation table, for this part is completely the same, just input the parameter of these PV panels. And for this part, you can get it from here. And here is your local temperature. And here it will get the results automatically. So if this is correct, and you can get for one string there is 21 pieces of the PV panels. And how many strings? You can get the P from here is 14 kilowatt. So finally we can get max 2 strings. And as for this one, it is the max 14 ampere for each string. This for you to do a double check. As for the A series, it is a little bit different, but generally it is the same. And for this parameter, you can get it from the nameplate. And also input to here, you can get that for one string there are 20 pieces of the PV panels. And also from the formula, you can get for this outdoor unit, for this A series, there are maximum 2 strings. And here is a summary for your reference. And for the top discharge and side discharge, you need to prepare for top discharge 42 pieces of the PV panels, and for side discharge only 10 pieces. And as for the PV panels, the lifespan, it is about 30 years, and with the decay factor less than 20%.
For the next part, we will talk about the wire connection. As you already know the difference between the Middle East and North American, and just due to this, the inside structure is a little bit different, but the function is almost the same.
And first, you need to decide where to install the PV panels, and which from these three, which is the best angle lying and the flag install. And this is the also flag install. And according to different cases, in the cement flag, steel roof is best for the factories, and this is the galvanized tile roof for the household use. So for this one, this is the before and after. And also for LV square meter, how many or how much power of this one can generate, we can also write here for your reference. After we install the PV panels, next is how to do the wiring, which is to wire them together. And it is very easy if you apply this MC4 fast connection. And we just combine the minus and plus together. You can also find it in this case, we just connect here. And this MC4, after you applied it, we just make the connect the pin is like this, and then insert this pin into this one and fasten it. It is very easy. And after you connect it, please check the open circuit with the multimeter. The voltage should be at this range for one string, and the difference between two strings, the voltage it should be less than 10 volt. If the wire is more than or longer than 200 meters, please consider the resistance. And the last is the most important. We require or we recommend to periodically clean the PV panels surface to ensure the efficiency. As you can find that the surface it will accumulate the dust which will lower the PV efficiency. And next is how to do the wiring from the PV panels or from the grid power supply to the PV GNV, which is this one. And from here you can find that we separate the power from the PV panels, and this is only for the A series as we don't have the converter, so we need to set up another converter. The purpose of this one is just to avoid the lining damage. And also the same for the AC distribution cabinet. This is also to avoid, the purpose is just to avoid the lining damage. If you have already fixed this lining damage, you can also combine them. You can also eliminate these two parts and do the wiring directly into the converter. Here is the requirements when you're going to do the wiring, especially for the PV panels. And the first is don't make a mistake between the positive and negative, which is this plus and minus. And then before you connect to the outdoor unit, please check the isolation resistance with the mega meter to ensure it is okay. And then also this cable also require protect. And then we're going to connect on the outdoor unit, which is on here. So you can find it on this outdoor unit terminals. This is for the power, you get it from the grid power supply AC. And here is connect to the indoor unit or the centralized controller communication wire. As for this one, it is for the PV panels from DC power. And also you can find it, it is a MC4 fast connection. As for the torque discharge, actually here the requirements is the same, and the difference is just the inside, how to do the wiring, which is this one. Actually, and here is the inside, you just open the panels. So at the front, the DC power, just get it from here, and the AC power, you get from here. And then, which is at the bottom view of this one, this DC power, you need to connect to here. And as for the AC power, just get through the hole and connect to the inside terminals. Next is the detail of how to do the wirings, and this example is for this model. And after you do the wirings of the PV panels, and just pay attention, don't mix the positive and negative. This one. And also check the isolation resistance with the mega meter before laying the cable down. And also this cable will require to do the protection. And on the outdoor unit, you just open the panels, and here is what you can see. And this is connected to the DC power, which is from the PV panels. So you can just plug in this MC4 into here. It's okay. And this is for the power supply from the AC power. And this is for the communication wire to the indoor unit and for the centralized control. And as for the C series, for the torque discharge, and for the requirement is the same, which is for this part is the same, and inside is just a little bit different. And here is the converter, and this is the PCB of the control. So, and also as you know that for the North American market, the converter and the outdoor unit, they are separated for delivery. So on site, you also need to combine them together. And here is this is the at the bottom side of from this one. So you need to connect the AC power to here, which is through this hole. And from the PV panels, you can connect directly to here, which is here. And also, as they are separated, this is converter separated from the outdoor unit. Also, you need to do the wiring, which is the VDC to here, and also the RS485 to here. And the other end is already connected on the outdoor unit. Which is here. This is RS485. As for the A series, and it is more easier, so you can find it. Here is for the communication wire to indoor unit or outdoor unit, and here is for the DC power supply. It is from the PV panels, and also here is for the AC power from the grid. And after that, you need to do the commissioning. This is especially for the top discharge and especially for the C series. So for that, just follow these steps. This is additional step just compare with the regular VRF, which including the QP, which is for the grid connection certification, and then QU is the power supply setting, and the QN is whether you need to upload or not upload to the grid power supply, which standard is this one. Also for this one, QP, according to different area, this is standard, and also the certificate is different. And also the QU is to set the three phases power supply, the parameter, including the voltage and the frequency. And the QN is to select whether you need to upload or not upload to the grid power supply. And after that, it's just the regular commissioning stage as the regular GMV. As for the commissioning methods, it's the same. You have this, you can do on this three, which is from the outdoor unit PCB, from the debugging software, which is from your PC, and this is the portable debugger. But the setting of these three parameters is only can be done on the outdoor unit PCB. And as for the side discharge, it can be done just after the commissioning and before the commissioning, especially for C series, you need to do this one. And for the last part is the investment analyzed. And first, we're going to have a look at this comparison between the top discharge A and C series. What's the difference between these two? And the difference, I already make it here. And also the important parts, I make it to be different color. So for the first one, it is whether you can link to the power module, which is whether you can stop the abandoned power to the battery. For the C series, is okay. And the second is whether you can upload to the grid power supply. For C series is available. And also, as you know that for the C series, there is a converter. The converter also has the combine function, which means this also with. And the last is the max PV input, and we increase from 12.5 kilowatt to 24 kilowatt, which has a higher capacity. And first, I will just make a comparison between the A series for top discharge and the C series, also top discharge. And here is the difference. The important part, I already make it to be different color. So the first one is for the C series, it is available to connect to the power module, which is the battery, to stop the abandoned power if you don't would like to upload to the grid power supply. And for the C series is available to upload, and also inside this combine box. And next is the max PV input. For the C series, we increase to 14 kilowatt. And last is the economy comparison. I just compare two plans. So for the plan A, it is a regular VRF plus the PV panels. So as it is a regular one, which means we need the converter. But for the plan B, it is the PVGMV, just plus the PV panels. And also from the outdoor unit, you can find it. This is the regular model. This is the PVGMV model. So next is the PV panels. As the power, as the capacity of the outdoor unit is the same, so the quantity and also the price for this part is the same. And for the converter, we need to set up for this one, and also additional installation cost, which means we need to connect the PV panels to the converter, and from the converter to the outdoor unit. Also, we need to cost the installation fee. So for general, the initial investment for the plan B, we can save about 3%. And then the next I will analyze from the operation, and this is the total power generation from the PV panels for the whole year. And you can find it, the total amount is the same, but just due to the efficiency, as you can find, just like what I introduced introduction. And for the PVGMV, there we can higher the efficiency, as we don't need to convert the DC to AC and AC to DC again, so we can save up to 6%. Is this 6? We can get 6% higher. So from the PV panels, we can also get 6% higher, right? So for this one, we can get higher PV efficiency. And so from this, we can convert into the power generation. And here is the totally for the 30 years, and just consider about the decay factor of the PV panels. You can find it drops every year, the decay factor. And finally, we can get the total power generation and divide it into 30 years. So we can get for every year, here is the power we can get from the PV panels. So from the plan A to plan B, here is the difference, which means for the plan B, we can get every year for this value, the power we can get from the PV power. And here is the total comparison. So for the PV panels, it is the same, and also the average annual power generation here is different. And according to your local electricity fee, which means this part, if it is higher, which means you can get a higher profit. So this is different, and so we can get the payback time. Just use this one initial investment divided this 3. So here is the result. It is about 4 months earlier you can get the payback. And that's all for this presentation. If you still have some problems or any questions, please feel free to contact me with this email address. So thank you again and bye bye.